All right, in today's lesson, we're going to be talking about linear correlation. And a correlation is basically a relationship between two things. So what we're going to be talking about is it's still going to have a linear pattern, but it's not going to be a perfect linear model. So where does this come from? It comes from more real-world data. And why would we have non-perfect real-world data? Well, think about it. You think about like age and height. So not everybody that is 10 years old is 4 foot or 5 foot tall. Okay, so I may have a 10-year-old that's 4'6", and I may have a 10-year-old that's 5 feet. They're close in height, but they're not exactly. So we wind up creating what we call a scatter plot. So these are scatter plots, and they're called scatter plots because we plot the data and the points can be scattered about. Okay? But what we're going to talk about today is what type of relationship happens with those scatter plots. So the relationship between two variables may form the pattern of a line. So it may look like somewhat of a linear pattern, but it's not a perfect linear pattern. And the pattern can be described in 3 ways. So how do I know if a pattern is strong? A strong pattern is a pattern that is grouped together in a cluster. They're grouped together more close together or close to each other. So when I look at this one, this pattern is very much linear in direction and is clustered together. They're grouped together. Now, this one is negative or strong and it's negative because it's going down. My pattern, my cluster, my scatter plots are going down in direction, which means as one increases, the other decreases. We also have a strong pattern, but this pattern is going to be strong and positive. Now, the reason this one is strong is because it's still clustered together. They're still grouped like a line, but this time they're going up. So they're both increasing. They're going up in direction. So these two are strong, and one is negative because it's going down, and one is strong because it's going up. Negative has nothing to do with strength. Strength means how close are they to each other. So then what we have a weak correlation. So weak or no correlation. So no correlation really means that they're just scattered about, no direction. It doesn't like it's really going up. It doesn't like it's really going down. It's just completely scattered. I would consider weak to be more of this example over here. Weak means I can still see somewhat of a grouping that's kind of going down here, but it's still very spread out, okay? So there is a difference between no and weak. So when we look at no correlation, that means that there is just no indicating pattern. But I could potentially have some that are still scattered out, but they're still kind of scattered out going down or still kind of scattered out going up, which would make it weak. Now, we also have what we call a correlation coefficient. Now, the correlation coefficient is represented by the letter R. And so we will get to a point where we actually find the line of best fit for this information, and it's going to give you R equals this. That R number tells you how good of a fit this information is to each other. So that R value is going to tell you 2 things. It's going to tell you the direction. So it's going to tell me the direction that my information is actually going. Is it negative or is it positive? And then it's going to give me the strength. Is it strong or is it weak? So that relationship is only going to happen with the correlation coefficient between 2 numbers. It's going to fall between -1 and +1. It can't fall outside of those 2 values, okay? So how do I know? Well, 0 means that it's going to be weak or no correlation. 0 itself means no correlation, okay? Now, as we move away from 0, so as I move away from 0, that's when I have a weak correlation. So what do I mean by that? So like let's kind of do negative 0.5 here and then 0.5 here. So we have the positive direction this way and we have the negative direction this way. So in the middle is no correlation. And then as we move out closer to -1 and move closer to +1, the stronger it gets. The difference is what direction with the negative and the positive. So if I have a number for R and that number falls between 0 and negative 0.5, then that's going to be weak and negative. Okay, so that's going to be weak and negative. Now, if that number on the negative side is between -5 and -1, that's when it's going to be strong and negative. So that's when we have that strong and negative correlation there. So this is where we have the strong and negative in that section. Now, the same thing can happen on the other side. So on this side, it's still going to be weak because it's still falling between 0 and 0.5, but this time it's going to be weak and positive. It's a weak number and it's positive. And then as we go to past 0.5 to +1, that's when it's going to be strong and positive. Okay, so the closer we are to 0, the weaker it is. So the closer we are to 0, the weaker it is. And then as we move to outside to closer to -1 or close to +1, the stronger it is. So let's talk about some examples here. So what I'm going to do is I'm going to flip over here, and I'm actually going to go ahead and go down to number 3. So if you look at number 3, they're basically giving you the R value. The R value is the correlation coefficient. So correlation coefficient is the R value that you would get when you do the line of best fit. So they want you to be able to tell me the two things. What direction is it going? And then on top of direction, can you tell me the strength of it? So is it positive or negative? Is it strong or weak? So when I look at negative 0.825. So negative 0.825, first thing I notice is that I have a negative number. So this is negative. So this is a negative correlation. And 0.825, if I think about my number line, is somewhere in this range. Okay? So 0.825 is past negative 0.5 and closer to -1. So we're going to call that negative and strong. Okay, so number 2 is positive 0.23. So this is positive, but 0.23, if I go back to my number line, 0.23 falls in this range right here, which is positive, but it's also weak. It's closer to 0 than it is to 1. So this is going to be positive and weak. All right, then we have 0.95. So again, that's positive. And if I go back to my number line, 0.95 is pretty close to 1. So that's going to be positive and strong. All right, and then the last one that we have negative 0.31. So again, this is going to be a negative direction. So remember, these are all the directions right here. These are the directions. And then these are the strengths. So you have to be able to tell me, is it going to be a positive direction? Is it going to be a negative direction? Is it going to be a strong relationship or a weak relationship? So this is my direction, and then this is my strength. All right, so negative 0.31. So negative 0.31, that's also going to fall between 0 and negative 0.5. So that's also going to be weak. And I also tell students, think about it like money, like 0.825. 0.825 is like 82 cents. That's closer to $1. That's going to be strong. 0.23 is like 23 cents. That's going to be closer to 0, so that's going to be weak. 0.95 is like 95 cents. That's closer to $1, so that's strong. And then 0.31 is like 31 cents. That's closer to 0, so that's going to be weak. And then you just have to remember the positive numbers mean it's going up, and the negative numbers mean it's going down, so it's negative. So is it true that a negative correlation is always a weak correlation? The answer to that is no. Negative has nothing to do with it being weak. Negative has nothing to do with it being weak. So we're going to say that this is false. And the reason it's false is because strength has nothing to do, so it's not equal to direction. Negative does not mean that it's weak. Negative just means it's going in a negative direction. Weak means that it's very scattered and it's closer to 0. All right, so let's go back up to the top. So it says, which scatter plot would have a correlation coefficient that has the highest strength? So to have the highest strength, that means that it's the one that is the closest together. So when I think about this, I think about, okay, if I were to circle these, I would say, okay, here's my circle here for that one. Here's my circle around these. Here's this circle around this scatter plot. And then here's the circle around this scatter plot. So if I look at this, I'm not asking what direction. I'm not asking, is it going up because it's positive or is it going down because it's negative? The one that is closest together is going to be A. A has the highest strength because it is closest together. C and D would still be considered strong, but they're not as strong as this one. This one is the most clustered together. This one right here really has no correlation because it's so scattered. So this one is basically no correlation. All right, so number 2. So we have the correlation coefficient and we have 0.95. So remember that number line, and we fall between 1 and -1 and then 0. So 0.95 is going to fall in this range, which is closer to, it's going to fall in this range right here, which is closer to 1. So that 0.95 right there, that means that it's going to be positive. So we can get rid of the negative. So that's negative, that's out. That's negative, that's out. So we have positive and weak and positive and strong. So 0.95 is closer to 1, so that's going to be positive and strong. All right, so looking at number 4. Number 4, it says I have a scatter plot here. That's what these is called, a scatter plot, when it's all clustered dots like that. And it says, which correlation coefficient best represents this data? So if we think about this, these are clustered together and they're going down. So they're going down in the negative direction. So I know that I have to have a negative correlation coefficient, a negative R. So if I need a negative R, that means I can get rid of A and B. So C is negative 0.34, that's weak. And then D is negative 0.94, that's going to be strong. So I would consider this more strong because it's more clustered together, making my correct answer D. All right, very similar. If I'm looking at number 5, I have this clustered together. These are clustered together in a pretty nice pattern, and it's going up. So since this is going up, I would be able to say that this is positive. So my R value here, because it says which one would be a reasonable correlation coefficient, it would have to be positive. So I'm going to get rid of my negatives. And then I need to figure out, is it 0.87? So this is on the stronger side. And then 0.23 is weak. These are clustered together. They're close together. So I would consider this to be positive and strong. All right, and our last one here. It says Trevor recorded the amount of material collected for recycling at his school for 5 weeks. Trevor calculated a line of best fit for the data to model the amount collected Y as a function of time. So what to know about is right here. It says he found that the correlation coefficient is between negative 0.7 and negative 1. So if I look at my number line that we've talked about previously, so here's negative 1, so here's 0. So negative 0.7 and negative 1 would fall in this range, which would mean it's closer to negative 1. So this is going to be negative, and it's going to be a strong negative because it's closer to negative 1. So this one says weak, we can get rid of that. This one says weak, we can get rid of that. So we know that these two are strong, which is good. But how do we know which one is negative? Well, you have to compare what it's saying. This one says that it increases as it increases. Well, increasing and increasing is going to produce a positive. This one says it decreases as it increases. Well, if I have a negative and a positive, then it's going to be negative, which is going to make my correct answer D. Now, when you get to your assignment today in Delta Math, it's going to give you a whole lot of information. And in that information, it's going to basically have, like an A, it may have a B, like here's A, here's B. It may have all kinds of stuff, but what you're going to focus on is it's going to give you a bunch of different examples. And in those examples, what you're going to focus on is only the R values, okay? So it may say which one of these is negative. So you're going to look for the one that's negative. It may say which one has the strongest relationship. That's what you're going to be looking for. So if I have negative 0.95 and I have 0.95 or 0.75, and it asks me which one has the strongest relationship. The one that has the strongest relationship is the one that's going to be closest to negative 1 or positive 1. So the strongest relationship is going to be that negative 0.95, because if I look at my range here, so we have 0 here. So 0.75 is like right in here, so 0.75. And then we have negative 0.95. This one is much closer to the negative 1 than this 0.75. They're both strong, but this one is the closest. This one is the strongest to the negative 1. So just keep that in mind. Do not make the mistake of thinking that negative means weak. Negative does not mean weak. Negative just means it's going down in direction. So which one is stronger, that's going to be the one that's closest to the outsides, and the outsides are 1 or negative 1.